Causal inference and generalizability both matter. Built into systematic or classic experimental designs are a number of design features that enable the capacity to make causal inferences. This includes that the independent variable precedes the dependent variable, that the researcher manipulates or has control over the independent variable, and that there are manipulation checks. There are ways built in to eliminate alternative explanations, including random assignment of participants to control and experimental groups. Generalizability is achieved via assessing external validity. First conduct the experiment, typically in the lab, and then get the effect. X causes Y. This then generalized to other people, other settings, other outcomes, and other conditions with other studies. As we discuss in our paper, situations that are not by design representative in the first place, they demonstrate external validity, but not generalizability to everyday life, what we refer to as gel. The extent of the problem that our findings may not have gel is unknown. Another design, called representative design, emphasizes generalizability. By using representative sampling of persons, stimuli, context, and their interactions, in developing the operationalizations of one's experimental and controlled conditions, researchers relying on sampling theory could build in gel. What about causal inference? This is only achieved statistically, but not by design. We suggest in our Psychological Inquiry Target article that a transformative synthesis, systematic representative design, or SRD, can concurrently enhance both causal inference and built-in generalizability to everyday life. This has been a labor of love for our research group, which includes communication scholars, psychologists, neuroscientists, media scholars, digital designers, public health scholars, artificial intelligence and engineering experts, and more. Therefore, I would like to invite all of my co-authors to describe what this theory means to them and the diversity of its applications.
Context matters, but it rarely it's defined. In my research, I investigate how resource contexts affect human decision-making and how human decision-making converges at the intersection of resource context, cognition, and artificial intelligence. This is where systematic representative designs come in. They will encourage researchers to identify contexts or environments before an investigation even begins. Thus, SRD has a potential to produce post hoc explanations and extrapolations of what an effect of a variable might be. Context matters, and therefore it must be defined.
This synthesis is enabled by leveraging today's intelligent agent, virtual environments, and other technologies. With SRD, researchers can now create a default control group in a virtual environment by representatively sampling from real-world narrative sequences, situations, and various behavioral options. We can create a representative virtual environment through detailed qualitative and quantitative analysis that draws on and replicates nuanced real-world experiences.
Some of the exciting possibilities afforded by these virtual human simulation tools include the tracking of precise measurements of human kinematics within interactions that have previously not been feasible. Such precision in VR affords both the representation and perception of subtle movements in terms of aberrations, combinations, and sequences that communicate nuances in human interaction that extend beyond those communicated by cruder categories of movements.
So normally in neuroscience, when you are doing experiments online, these are not very representative of everyday life. They're not naturalistic much of the time. And so one thing that SRD can do is it allows us to think about different levels of scale and to use representative designs within neuroscience and other kinds of biobehavioral approaches as well, and to tie across these different levels of scale in a way that we haven't done before.
Systematic representative design is a methodology through which big data can be leveraged to better create systematic control and experimental groups, and more systematically test how to structure data contextually, so that we can build better predictive models of human smartphone and sensor data patterns over time. In my latest project, which is related to COVID-19, I'm just now starting to uncover the depth and complexity of big data. And honestly, it was quite overwhelming at first. But the systematic representative design approach has provided me with a clearer sense of how to navigate these waters and solve health communication problems that I've never been able to tackle before.
Through 4 studies, we have found that the decisions that participants make in these environments are correlated with their everyday decisions in the real world. That is, these environments exhibit virtual validity. We can then build experimental groups with systematic manipulations onto the default control group base and comparatively test these interventions in randomized controlled trials. Applying systematic design features like random assignment then afford valid causal inferences and generalizability from the original representative design.
Systematic representative design is a powerful new tool, not only because it speaks to our fundamental human need to believe that we're not limited by our histories, that we can recreate ourselves, but also because the self-transformation can have constructive functional significance in the real world. We can try an intervention in a virtual environment, see if it works, make changes, and then test again, rinse and repeat, if you will. In this way, we can adjust participants' behaviors on a granular level with adjusted interventions. We are advancing a cumulative science, optimizing personalized risk reduction through tailored interventions the same way modern medicine is using personalized gene therapy, which is really incredible.
We also discuss how the approach is already advancing a computationally enabled social science across disciplines and demographics through rapidly scalable and effective nationwide interventions for addressing real-world communication problems.
It's the notion that social science research has been dominated by weird samples, that is, Western, educated, industrialized, rich, and democratic. As a research scientist, the emergence of a society seemingly unable to agree on objective reality and facts raises empirical questions of the utmost urgency. Through the reach of technology, systemic representative design allows for the inclusion of understudied samples in generalizable and personalized SRD virtual environments. And this may allow us to better understand the decision-making and mental models of a broader range of individuals, that is, the non-weird.
It is possible today to generate representative social interactions with diverse others in representative narratives. I like this passage because I read it as hopeful about the evolving potential for science to help solve social issues. I know that each author of this paper values diverse perspectives and strives to elevate them in their work. And I think an underlying theme in our paper is that science can and should do good for the world.
Some of this very exciting work where increasingly intelligent agents have an underlying model of the world that we can use to test our own model of ourselves as human beings. So if we have a model in communication that goals and beliefs and so forth are important, we can specify those parameters and test those models directly as part of a bigger science. So there are some advantages to this approach in taking us to places in communication and social science where we haven't historically been.
Generalizing to everyday life is the goal of social science. And the fact that this isn't plausible with more traditional and accepted methods is a serious flaw. Media does not exist in isolation, but the studies of media effects that have dominated the discourse for over 75 years attempt to isolate media. SRD transforms media studies by building in the inherent complexity of real life and allowing participants to play while researchers observe, manipulate, and ultimately come to understand human cognition in the real world.
So my favorite part in this paper is that we argue that we might be at the tipping point for a paradigm shift in experimental design. For a while, faced with the challenges of creating replicable and generalizable experiments, us communication researchers dodged the question by trying to frame the goal of social experiments as testing the boundaries of science rather than to generalize science. Here in our paper, we proposed another possibility, which is systematic representative design. This is what I believe to be the most inspiring part of the paper. Yes, with a little bit of courage to cross the boundary, we may be able to find a better solution for social science experiments.
What's exciting about being on this team is that there are so many different perspectives. There are so many different skill sets. There are so many different capabilities that make it possible for us to think about a social science that could do amazing things way beyond what we seem capable of doing at the moment. And I would love to end my career in however many years, with the thought that all of these young people who are starting out in the field today will just have an amazing set of opportunities and an amazing set of tools to really advance social science and communication in particular in the years to come.
Excellent.
Good to see everyone.
Good to see you, everyone.
Have a wonderful Saturday. Stay safe. Bye, Lynn.